Okay, so we're going to look at a power of a product property. And you'll notice here I have our variables set up. So what do we do in this situation? I'm going to use this term loosely, but we're basically going to distribute the exponent to both terms. And so it'll end up being a to the n times b to the n. And notice these guys are different bases right here. So I cannot combine the a and the b. The exponent just gets attached and then we're done. If we could simplify anything further, we would. Let's kind of explain what's happening here using some numbers. And so if I had 2 times 3 all raised to the second power, order of operations and your intuition is going to tell you that, well, we need to multiply or work with what's in the parentheses first, right? Because that's what order of operation tells us to do. So that would end up being 6 squared, which is equal to 36. But because of some of the special properties of multiplication, dealing with this exponent, I can actually approach this problem a different way. I can take 2 squared times 3 squared, and that's going to equal 4 times 9. Well, what's 4 times 9? 36. We get the same answer, so the shortcut here is to just distribute the squared term. Because it's numbers, I can put everything together. And this is helpful when we're dealing with variables in order to simplify a more complex expression or equation. We could use this property. And so we'll go ahead and we'll look at a different example using variables. Okay, so another example here, but just using variables. We're going to go ahead and say, hey, okay, we got x times y raised to the third power. Because of this property up here, I just say, okay, x to the third, y to the third, and that's my final solution. We're going to go even further with another example, and let's say that what's inside had exponents. Okay? Well, what we're going to do here is we're going to go ahead and whatever this exponent is right here on the outside, any exponent that's on the inside is going to get multiplied. And in our previous example, notice there was no exponent. When there's nothing listed, we actually have it as 1. There's only one of those guys. And so 3 times 1 is 3, and 3 times 1 is 3. So that's why we ended up with just the 3 and the 3 here. So with this one, to write it out a little bit, we're going to have x squared times 3, and the 3 is coming from here. We're going to have to do the same thing again with our y variable. Once again, that 3 is coming from the exponent on the outside. We're going to go ahead and simplify here, and we get x to the 6th times y to the 9th. And that's our final answer. Okay, we'll do one more example here real quick. And let me just get one going here. Let's say we have 3 terms. Okay, same process, just a couple extra terms. So let's say I had x to the 4th, y to the 3rd, z to the 7th squared. So what I'm going to do is I'm going to think to myself, I'm just going to take this term right here, this 2, and I'm just going to multiply it with the exponents for each variable listed in the expression. So that means 2 times 4 is 8, 2 times 3 is 6, and 2 times 7 is 14. And there we go. That is the power of a product property.